Hello everyone, I'm Rong Han, a data science student. Today, I would like to explain the application of derivatives to economics and the Washer method to find the volume of a slot of revolution and the moments at the center of mass to you. Let's start. First is the derivative. Derivatives are fundamental in economics for analyzing changes and optimizing outcomes. And let's talk about the functions about this. First is cost function. The cost function represents the total cost of producing units of a good, and its derivatives give the marginal cost, which is the rate of change of total cost with respect to output. Marginal cost tells how much it costs to produce one additional unit. And for example, if Cx equal to 100 plus 10x plus 0.5x squared, then the marginal cost is the derivative of Cx, and it's equal to 10 plus x. And when x equal to 10, the marginal cost is 20. Second, let's talking about average cost function. It represents the cost per unit of production. To minimize average cost, find the determined derivative and solve. Revenue. The third is revenue function. The revenue function represents the total revenue from selling units of a good at a price. Its derivatives, the marginal revenue, indicates the additional revenue from selling one more unit. Okay, let's see the example. If the price stem function is px equal to 50 minus 2x, then rx equal to x times px. The marginal revenue is the derivative of rx. It's equal to 50 minus 4x. And we can say that rx equal to 10. The marginal revenue is 10. And we can calculate this. The fourth is average revenue function. It represents revenue per unit. The derivatives of help determine output levels via revenue per unit change. And the fifth is profit function. It's very important to us. Its derivative, the marginal profit, shows the rate at which profit changes with production, maximizing profit involving solving. Let's see this example. If Rx equal to 50x minus 2x squared and dx equal to 100 plus 10x plus 0.5x squared, then we can get px through rx minus cx, and the marginal profit is the derivative of px equal to 40 minus 5x, and we set in px, the derivative of px equal to 0, we can get x equal to 8. So the profit is maximized at x equal to 8. And the sixth is average profit function. Its derivative helps find the production level where profit per unit is maximized. Let's summarize. Marginal cost, rate of change of cost with production. Marginal revenue, rate of change of revenue with production. And marginal profit, rate of change of profit with production. Derivatives help determine optimal levels of output to minimize cost, maximize revenue, or maximize profit through these ways. Okay, let's talking about the Washer method. Washer method is a technique used to calculate the volume of a slot of revolution when the slot has a hole or empty region in the center, like a washer. It extends the depth method by subtracting the volume of the inner slot from the outer slot. And what is washer? A washer is a flat raking like shape formed when a region between two curves is revolved around an axis. The washer has an outer radius and the inner radius. And let's say the steps of using the washer method. First, we need to sketch the region. And second, determine the radius, outer radius and inner radius. The third is set up the bounds. Identify the limits of integration. And fourth is set up the integral. Substitute and into the washer formula. And fifth, solve the integral, compute the integral to find the volume. And the formula for the washer method, the volume of the slot of revolution is given by this equation. From this, we can get that A and B, the bounds of integration, is very important. But if the slot is revolved around the y-axis or a horizontal axis, the formula is expressed in the terms of another way, such as like this. Okay, and let's say an actual example. Look at this question. Find the volume of a slot formed by revolving the region bounded by y equal to x squared and y equal to 4 about the x-axis. First, we need to find the outer and inner radius. We can see that one is 4, one is x squared, and the second we need to find the region is bounded, and we can get x equal to -2 and x equal to 2. And for third, we set up the integral, and fourth, solve the integral, and then we get a final answer. The final answer is this. And attention please in the fourth step, because the function is symmetric, so we can calculate the integral from the 0 to 2 and let the result equal to double of the integral from 0 to 2. It's a more easier way for us. And the summary of this impact of the washer method. First is solve complex problems. Or the washer method allows us to calculate volumes of slots with whole regions, which is common in engineering and physics. And then is flexibility. It works for both horizontal and vertical axes of rotation and accommodates irregular shapes. The third is real-world application. The method is used in designing objects like pipes, rings, and machine parts where whole regions are essential for function or material savings. The fourth is integration of geometry and calculus. It combines geometric understanding of cross-sectional areas with calculus for precise volume computation. And let's talk about the moment and center of mass. The concept of moments and center of mass arose from physics and calculus. They help describe how mass is distributed and balanced in an object or system. Moments. The moment of a system measures the trains of a force or mass to rotate around a point or axis. Moment about a point for a system of particles. The moment about a point is the sum of the products of each particle's mass and its distance from the point. Just like we can say about this formula, it gets through M1, M2, and until M10, Mn. located at points x1, x2 until xn on a line. The moment about the ring is this, and the moment of a continuous mass distribution. For an object with a continuous mass distribution along an internal, the moment is this. We can get the moment through this formula. And we know that rho is the linear density function. Okay, let's talking about the center of mass. The center of mass is the point where the mass of an object or system is perfectly balanced for a system of particles or a continuous distribution. For a system of particles, the center of mass is given by this formula. And for a continuous mass distribution, the center of mass is given by this formula. If the object lies in two dimensions, we compute moments at centers of mass along both axes. Let me combine this and this. Okay, let's talk about the actual problem. If we meet a question about find the center of mass of a rod of length 4 meters with a density function rho x equal to x, where x is the distance from one end. First, we need to get the total mass. The total mass is the integral of the density function over the length of a rod. And then we get moment about the arranging. The moment about the arranging is about get through this. And third way, we get center of mass. The center of mass is 8/3. And then we get the final answer. The center of mass of the rod is located at 8/3. Or you can also approximately 2.67 meters from the left end. Okay, conclusion. Moments and center of mass are essential tools for analyzing balance, stability, and motion in physics systems. They play a vital role in engineering, architecture, physics, sports, and robots, enabling better design, optimizing, and understanding of real-world phenomena. And okay, that's all. Through today's hearing, we learn about the important applications of calculus in various fields, especially economic and geometric and physics. It is very important to learn calculus well. Through this class, we know that it is very important to learn calculus well. It benefits to our daily life. And thank you for your listening. Bye.